Imagine a particle as a wave of probability, existing everywhere and nowhere at once. This is quantum superposition. Quantum superposition is a state where a subatomic system holds all possible realities simultaneously. But the second a beam of light hits it, the moment it's observed, that blurry wave collapses into a single, sharply defined point of solid matter. Erwin Schrödinger wrote an equation that maps exactly how this probability wave ripples and flows over time. The Schrödinger equation is the foundational mathematical formula of quantum mechanics. Yet within that formula, there is absolutely no mechanism that describes the collapse itself. The math tells us what happens before we look and what happens after, but the actual act of observation is a blank spot in the laws of physics. This gap is known as the measurement problem. For decades, the orthodox view was the Copenhagen interpretation. The Copenhagen interpretation is a theory pioneered by Niels Bohr and Werner Heisenberg, stating that the universe remains unresolved until the act of measurement forces it to make a choice. Under this rule, physical reality only solidifies when an observation takes place. But that rule carries a fatal flaw. It completely fails to define what qualifies as a measurement device. Does collapsing a probability wave require a conscious human eye, a camera lens, or just the click of a vintage guide? The physics community fractured. Scientists spent the last century building a spectrum of competing theories, arguing over exactly how much power the observer wields over reality. This missing math forces us to confront an immense question. If the equations of the physical world break down at the exact moment of observation, does the universe require us to look at it in order to exist? At the lowest end of the observer spectrum sits a theory called decoherence. Decoherence is a framework suggesting that reality forms through automatic physical interactions, requiring absolutely no human consciousness to collapse the wave function. Under this model, an observer is simply the environment itself. When a delicate quantum system bumps into anything around it, a stray photon, a speck of dust, or a molecule of air, its state is immediately altered. That physical bump causes the quantum coherence to leak away. The wave breaks apart, its fragments dispersing and blending into the chaotic background field, locking the superposition into a single classical reality. The implications are completely grounded. The world around us forms through blind, microscopic collisions. Conscious observers are entirely unnecessary for the universe to function. Moving up the spectrum, we reach Hugh Everett's many worlds interpretation. The many worlds interpretation proposes that every possible alternate history and future is real. Its premise removes the collapse entirely. The wave function never actually collapses. Instead of the probability wave shrinking down to a single point, the measuring device and the observer operating it become physically entangled with the quantum system. Entanglement is a quantum phenomenon where separate entities become inextricably linked, sharing the same mathematical state. As a result of this entanglement, the entire universe splits. Every possible mathematical outcome happens simultaneously. Each divergence creates a parallel timeline, and a different version of the observer is duplicated onto each new path to witness that specific result. Because these branches are permanently cut off from one another, the observer is completely blind to the split. Moving forward on a single isolated path, they feel as though the universe simply made a single choice. In the many worlds model, the observer holds no special power to force reality into shape. They merely become a participant trapped inside one narrow sliver of an ever-expanding multiverse. At the extreme end of the spectrum is the von Neumann-Wigner hypothesis. This theory places human consciousness squarely at the center of reality creation. John von Neumann identified a paradox called the von Neumann chain. The von Neumann chain highlights that if the camera, the eye, and the brain are all made of quantum atoms, they should not be able to force a collapse, but should instead enter into a blurry superposition right alongside the particle. Their conclusion was that physical matter cannot collapse physical matter. The only mechanism capable of breaking the quantum chain and snapping the wave function into a definite state is a non-physical consciousness. Physicist John Wheeler pushed this concept to its absolute cosmological limit with his it from bit theory and the delayed choice thought experiment. It from bit is the hypothesis that all physical things derive their existence from binary yes or no questions posed by measuring devices. Wheeler revealed that an observation made in the present day can actually dictate the path a photon took billions of years in the past. By choosing how to measure light from a distant quasar today, the observer reaches backward through time, forcing the photon to have traveled a specific route. Wheeler described this as a self-excited circuit. We do not passively watch a pre-existing universe. By asking it questions, we actively bring it into existence, building both the present and the deep past with every observation. Does reality require an observer to exist? While the physics community has yet to reach a consensus, modern researchers are actively testing these boundaries. Recent experimental breakthroughs, like the extended Wigner's friend tests and the Big Bell test, are probing whether facts can exist independently of an observer. The Big Bell test was a global experiment that used human choices to control quantum measurements, proving that conscious agency affects quantum outcomes. The data from these tests point to a startling implication. Objective reality may be an illusion. If two observers measure the same quantum system, they can record completely different, yet equally valid, results. Facts might be entirely relative to the person observing them. Whether you subscribe to the blind physical interactions of decoherence or the conscious creation of Wheeler's participatory universe, one truth remains inescapable. The observer is an inextricable component of physics. The universe is not a static museum we passively walk through. It is an actively unfolding event. The mere act of looking is the ultimate act of participation.